In this video, we're going to look at graph transformations and modulus graphs as well. So not only are we going to look at f of the modulus of x, but a lot of my students struggle with the modulus of f of x itself. So we'll have a look at that as a bonus part of this question. Okay, so let's try zooming in to see what happens. So with this, you want to break it down into individual parts. So you want to first apply the change that's happening inside the bracket, which is f of 2x. What that does is it halves all the x values. So 4 minus 2, the x value of 4 would be halved to 2 minus 2 because the y value would stay the same. This minus 1, 3 would be halved so that it would now be minus 0.53. So essentially the graph would look like it's being squeezed together, if that makes sense. Sort of like this. Same graph but squeezed together. Now 3f of 2x, what that does is it multiplies all the y values by 3. So now I'm just going to draw on top of this with the red pen. But instead of minus 0.53, we're going to have minus 0.56 because the y value is going to be doubled. Similarly, instead of minus 2, 2, we're going to have 2 minus 2, we're going to have 2 minus 4. So the graph is going to be squeezed close together, but also larger in terms of y. So it'll look something like that. Hopefully that makes sense. But the main ideas you want to go through is just what happens to the stationary points. So it'll become minus 0.56 and 2 minus 4. Sorry about my handwriting, but yeah, that's what would happen for the first part of the question. Moving on to the next question. Just a reminder, by the way, you always want to apply what's happening inside the bracket before what's happening outside the bracket. F of the modulus of x. Well, what significance does that have? Let's put this on the board. Well, the modulus of minus 3 is equal to the modulus of 3 because both of them are equal to 3. In the same way, f of the modulus of 3 would give f of the modulus of minus 3. That means that when you put x equals 3 into a function and x equals minus 3, it'll give you the same y value when we're looking at the graph of f of the modulus of x. That means all the positive x values give the same y values as all the negative x values. This x value of 4 gives y equals minus 2, so the x value of minus 4 would give a y value of minus 2 as well, if that makes sense. So all that would happen is the graph would be reflected so that everything on the positive x-axis gets reflected on the y-axis so that it reflects in that way, forming a sort of W shape. Hopefully that makes sense to you guys. Let's now move on to the modulus of f of x, something else that students struggle with. So the modulus of f of x, well, the modulus of anything, it can't be negative. That means that everywhere where the graph is negative, you actually reflect it this time in the x-axis. So reflecting this section in the x-axis, it'll look something like that. You can cross this off. Reflecting this section in the x-axis, it'll look something like that. You can cross this off. And that's it. Hopefully that helps you understand how to go about doing this question and how it then affects the stationary points. So this stationary point, it would disappear for the graph of f of the modulus of x, and there would be another one at minus 4 minus 2. Sorry, I forgot to label that. Do be sure to leave a like if the video did help and subscribe. I'd appreciate a lot. Thanks for watching. Thanks for watching the video, guys. Hope it helped. If you have any A-level maths or physics tutoring inquiries, be sure to send me a message at www.excelineducation.co.uk.